Hello everyone, my name is Namrata Ghag and I welcome you all for the video streaming of Ansys Workbench. Ansys Workbench is a CAE software which we are covering for 80 hours, and during these 80 hours we will be covering all the topics that you are seeing on your screen now. We will be starting with the introduction of CAE, and then we will enter into the software and understand the software capabilities for creating the models and for analyzing them using the different types of analysis that are there in the software. So let us begin with the first chapter, that is Introduction to CAE. In this chapter, we will be understanding what is CAE, the basic concepts that are involved in CAE, what is FEA, what are the advantages and disadvantages of FEA, what are the types of analysis that can be performed, and also some of the important definitions that are there in FEA. So let us start. What is CAE? CAE stands for the Computer Aided Engineering. It is the use of a software to simulate performance in order to improve product designs or assist in the resolution of engineering problems for a wide range of industries. What does this mean? We will be using the software for analyzing the designs and improving the designs. CAE software also includes simulation, validation, and optimization, which means that we can simulate our designs by analyzing it. We can also validate our design. That means when we analyze the design and we understand that there are some problems in the design, there are some mistakes that are there in the design, we will be validating it. That means we will be correcting our designs so that we don't scrap the design. We will be involving in the correction of the design also. And then also we can also be perform the optimization procedures to achieve better designs. Now, why should we use CAE software? Whatever products we are designing, they have to be according to the customer requirements. And it is very important to analyze the design to understand whether the design is performing according to the customer requirements or not. What are the benefits of CAE? If we use the CAE software, it helps us make better decisions regarding the designs, material, and other economic factors. It also enables us to maintain standards throughout the designs and manufacturing. The use of CAE software also helps us to reduce the product development cost and time while improving the safety, comfort, and durability of the components that we produce. What are the application areas? CAE can be used in different fields like aerospace, automobile industries, energy, heavy machineries, marine industries, medical areas, consumer products, and many more such. Now let us discuss about another important concept that is involved in CAE, that is FEA. FEA is the study of behavior of components in real-time conditions in CAE that is achieved through finite element analysis. It is a computing technique that is used to obtain approximate solutions of boundary value problems. It uses a numerical method in this, which is called as FEM, that is nothing but finite element method. Now let us understand what exactly is FEA. For this, what we will do is we will consider a small example where we need to find out the area of this circle. Now for calculating the area of the circle, we will not use the formula that is pi r square. We will be using a different technique. Now what is that technique? Let us divide the circle into 4 triangles. If you see on your screen over here, you can see that I have divided the circle into 4 segments and then connected these lines over here so that it forms a triangle. Now we will find out the area of one triangle and then sum it up so that we get the area of the circle. But in this case, you will see over here that this area is left out. So this is the error that I have got in the solution. So to reduce that error in my solution, we will go to the second step where now instead of 4 segments, I have divided the circle into more number of segments. Now as we have increased the segments, the area of error, if you see, the area of errors has now reduced. With this, we will understand that if we divide the circle into more number of segments, the accuracy will increase. But with more number of segments increase, the time required for calculating the solution is also increased. So the same concept we can apply in FEA, that is, if we want to have a better solution in FEA, we need to have more number of elements or more number of divisions. But if we divide the object into more number of elements, we will also have to spend more time in calculating the answer. So FEA is a compromise between accuracy and speed, but the compromise between speed and accuracy makes it an approximate method. Earlier, FEA was only developed to analyze the products that were used in the aerospace industry. But nowadays, you will see that FEA is used in all the industries and it is used for analyzing all the designs that we are creating. Now, when we talk about an engineering problem can be solved in three different methods, that is, experimental method, analytical method, and numerical method. What is that experimental method? Now, experimental method is nothing but it uses a prototype of the actual model and it is then tested under the real-time conditions so that we understand how the design will behave in the real-time conditions. This method gives us the most accurate results, but it is very costly and time-consuming. The second method is analytical method. Analytical method is actually very difficult, but this provides very accurate solutions. Now, you must have heard about the Rayleigh-Ritz method and the partial differential equations. They are actually examples of analytical method, but you know how complex it gets when your design gets more and more complicated. The equations will also get more and more complicated, and hence it takes a very lot of time to analyze the solutions. Third method is the numerical method. Nowadays, numerical method has become very popular for solving the engineering problems. The numerical method gives the most approximate results, but still it is used in many areas. And it will be using methods like finite element method, that is FEM, boundary element method, volume element method, and so on. Now, to understand more about the analytical method and numerical method, we will be considering one simple problem. If you can see, there is a small problem on your screen right now. We will be solving this problem using both the methods, that is the analytical method and the numerical method. Now we have one stepped bar over here. The cross section of the stepped bar can be anything. It could be circular, rectangular, or any other shape. And this stepped bar is subjected to a load over here. And the lengths of the step bars are also given, and A1 and A2 are the areas of the cross section. So let us understand this now. How to solve this using analytical method and the numerical method. Okay, so if you see over here, this is the same problem. You can take down the data over here. P, that is the force that is applied on the step bar, is 200 newtons. Area 1 is 200 millimeter square. Area 2 is 100 millimeter square. Length of the step bar is 100 millimeters for each of the step bar. And E, that is the Young's modulus, is 200 GPU. And we are supposed to calculate the stress induced in this step bar. So the first method that we will use is the analytical method. Now, in the analytical method, the first formula that we will consider is, if I need to calculate the stress, I know the formula for that, that is P upon A, that is force upon area. For calculating the strain, we know the formula, that is change in length upon the original length. Now, Young's modulus is stress upon strain, that is, you can consider this formula if you consider the Hooke's law, that is, the change in length is within the elastic limits, means when the force is getting applied on that stepped bar, when we apply the force on the stepped bar, it will undergo some change in length. But if I remove the force, it will regain its original shape. That means the deformation that we will get is within the elastic limits. Hence, it follows the Hooke's law, and we can consider this equation over here, that is E is equal to stress upon strain. Now, according to this, if we simplify this equation, we will see that stress is P upon A and multiplied by L upon dA. Now, let us solve this equation. So, if I take change in length on one side, the equation becomes PL upon A, that is force multiplied by original length upon area into the Young's modulus. Now, let us calculate the change in length for the first bar. So, the formula becomes P into L1 upon A1 into E. So, if I enter all the numerical values, the change in length in the first bar is 0.5 multiplied by 10 raised to minus 3 millimeters. Similarly, let us find the change in length in the second bar, that is dl2. Again, if we enter all the numerical values, we will get the change in length in the second bar is 1 into 10 raised to minus 3 millimeters. Now we have got the change in length in the first bar and the second bar. So let us calculate the strain. So strain in the first bar is change in length in the first bar upon L1. That gives me 0.5 multiplied by 10 raised to minus 5. It is a unitless quantity. Similarly, strain into the second bar is TL2 upon L2, which is 1 multiplied by 10 raised to minus 3 upon 100, which is equal to 1 into 10 raised to minus 5. Similarly, we will calculate the stress in the first bar and the second bar. So, P upon area 1, P upon area 2, that is 200 upon 200, that is stress in the first bar is 1 Newton per millimeter square, and stress in the second bar is 200 upon 100, that is 2 into 2 newtons per millimeter square. Now let us move to the next method, that is the numerical method. In numerical method, we will be considering the same problem that we considered for the analytical method. Now if you can see over here, it's the same step bar that we have. We have area 1, area 2. The load applied on the step bar is P, and the length of the step bar is L and L. Now this step bar model that we have, we will convert that into a free body diagram. Now when you convert that diagram into a free body diagram, you will notice that I have marked something called as N1, N2 and N3 over here. Now N1, N2 and N3 is nothing but the nodes which connect the two bodies over here. That is the first body and the second body. Now let us start with the numerical method. Now at the starting of the numerical method, we will first consider the elastic behavior of a linear spring equation. If you can see over here, we have drawn one linear spring whose stiffness is K. The load applied at this point at the end of the spring is P, because of which there is a change in length that is called as dl. So if you consider the linear spring equation, the equation states P is equal to KdL, where P is the force applied, dl is the change in length, that is the displacement, and K is the stiffness of the spring, that is the spring constant. So if you take K on the opposite side, you will see the equation becomes K is equal to P upon dl. Now we also know from the previous solution that we've done for the analytical method, E is equal to stress upon strain, that is if it is within the elastic limits, that means if it follows the Hooke's law. So our equation becomes P upon A into L upon dl. So now if we simplify the equations, our equation becomes P upon dl is equal to AE upon L. That becomes equation number 3. So if we compare equation 2 and equation 3, our equation can become K is equal to AE upon L. Please see carefully what we have done over here. Okay. Now we will be assuming applying the Newton's third law for the reaction forces. Now first we will consider the first step bar. Okay. So if we apply the Newton's third law of the reaction forces for the first bar, we will apply force at I. Okay, we will be applying force at I. and we will be locking J. That means I will be applying a force over here at the I node and we will lock the J node. If we do that, we will get an equation of stiffness, that is K1 is equal to K1. I am writing K1 because we are considering this in the first part, and K1 becomes, we are writing a stiffness matrix equation for the first step bar. It becomes A1 into E upon L. So the reaction for this is minus minus A1E upon L. Similarly, minus A1E upon L and A1E upon L. We are getting this by the Newton's third law. Every action has an equal and opposite reaction. Due to this, we are writing this equation. Okay. So this we have assumed for the first bar. Similarly, we are going to make a similar assumption for the second bar. So now what we are doing is we are applying force at the J node and we are locking I. So if we do that, now this is going to happen for the second bar. Okay, we are doing this for the second bar. In the second bar, we are applying force at J and we are locking I. So the stiffness equation becomes like this: A2E upon L minus A2E upon L minus A2E upon L, A2E upon L. Okay. Now I am going to calculate the global stiffness matrix. So global stiffness matrix is K, which is equal to K1 plus K2. So we have to add both the stiffness matrix. So now by combining both the stiffness matrix, that is K1 plus K2, you get this global stiffness matrix, that is K. Okay, so I have directly solved this and we get this global stiffness matrix. You can solve the same thing in your notebooks. So this over here is the global stiffness matrix that we have got. Now let us see what are the properties of a stiffness matrix. K stands for the stiffness matrix. So every stiffness matrix has some property. Now what are these stiffness matrix properties? If you look at a stiffness matrix, it will always be a square matrix. That means the number of rows and the number of columns will be equal. It is always a symmetric matrix along the diagonal. So if you take any diagonal over here, if I take this as the diagonal, you will see that it is symmetric above the diagonals. Can you see? If I take this as the diagonal, again it is symmetric. The algebraic summation of any row or any column is 0. If you add up any row or any column, the answer that you will get is 0. You can check the same for yourselves. The stiffness matrix always and only contains the geometric and material properties of the problem. If you look at the constants A1, E, L, A1 becomes the geometric property, L also becomes the geometric property, E becomes the material property. Apart from geometric and material properties, it does not have any other property. So that is why the statement that the stiffness matrix always and only contains the geometric and material properties of any problem. Okay, now let us go forward. Now we will put in the numerical values that we considered for analytical method. We will be considering the same values, and let us put all these numerical values in the global stiffness matrix and let us solve this equation. So my equation becomes something like this: 200 into 2 into 10 raised to 5 upon 100 minus 200 into 2 into 10 raised to 5 upon 100, 0, minus 200 into 2 into 10 raised to 5 upon 100, 200 into 2 into 10 raised to 5 plus 100 into 2 into 10 raised to 5 upon 100 minus 100 into 2 into 10 raised to 5 upon 100, 0, minus 100 into 2 into 10 raised to 5 upon 100, 100 into 2 into 10 raised to 5 upon 100. So we've got this by putting in all the numerical values in this equation. Further, we will solve it. Now what we have done is we have taken 10 raised to 5 outside and we have solved the equation. So our equation becomes 4 minus 4, 0, minus 4, 6, minus 2, 0, minus 2, 2. You can check this by solving this equation in your own notebooks. Now, again from the linear string equation which we considered at the beginning of the numerical method here. So if we consider the same linear string equation here, okay, KDL is equal to P. But in this case, we have put them into brackets to show that this is a vector quantity and even P is a vector quantity. K is our stiffness matrix. Phi over here stands for the change in length and P over here stands for the force applied. So, if I consider the free body diagram, that is N1, N2 and N3. So the change in length, we will have different change in length at every node. That is, I will have a change in length at N1, I will have some change in length at N2 and I will also at N3. So if we consider the load applied at N1 is P1, load applied at N2 is P2 and the load applied at N3 is P3. Similarly, the change in length at node number 1 is phi1, the change in length at N2 is phi2, the change in length at N3 is phi3. So now we will be putting this into a matrices format. So stiffness matrix, whatever value we have got, 10 raised to 5 into matrices format, 4 minus 4 0, minus 4 6, minus 2, 0 minus 2 2. Change in lengths into the matrices format, we have written it as phi1, phi2 and phi3. Similarly, load acting at all the three nodes over here, P1, P2 and P3. Now, because node number 1 is completely fixed, the degrees of freedom over there are 0, there will be no change in length. That means phi1 will be 0. So, because in the matrices format, when you are multiplying two matrices, if any row or any column becomes 0, we can cancel out the entire first row and the first column. So now my equation becomes 10 raised to 5, 6 minus 2 minus 2, 2, phi 2, phi 3 is equal to P2, P3. Why we have done that? Because phi 1 becomes 0 as there is no change in length at node number 1. Now further, we will convert this into a simultaneous equation. So let us open up the equations. My equation now becomes 10 raised to 5, 6 phi 2 minus 2 phi 3 is equal to 0. That is P2 0 and 10 raised to 5 minus 2 phi 2 plus 2 phi 3 is equal to 200. That is P3. So now we will solve the simultaneous equations. So now my simultaneous equation becomes something like this. 4 phi 2 is equal to 200 upon 10 raised to 5. Phi 2 is equal to 200 upon 4 into 10 raised to 5, which becomes 0.5 into 10 raised to minus 3 mm. So now I have got the value of phi 2. We will calculate the value of phi 3. So if you substitute the value of phi 2 in any equation, you will get the value of phi 3, that is phi 3 is equal to 1.5 into 10 raised to minus 3 mm. So phi 1, phi 2 and phi 3 are the change in lengths at the different nodes N1, N2 and N3. Now from these values we will be able to calculate what is the change in length in the entire bar. So for getting the change in length in the first bar, our equation becomes phi 2 minus phi 1, that is dl1, change in length in the first bar. So now my equation is phi 2 minus phi 1. Phi 2 we have already got it as 0.5 into 10 raised to minus 3 minus phi 1. Phi 1 becomes 0. So my answer is 0.5 into 10 raised to minus 3. Similarly, dl2 that will become phi 3 minus phi 2. It becomes 1.5 into 10 raised to minus 3 minus 0.5 into 10 raised to minus 3. So my answer is 1 into 10 raised to minus 3 mm. From dl1 and dl2 we will be getting the strain values, that is change in length upon first upon L, that becomes 0.5 into 10 raised to minus 5. Strain in the second bar is 1 into 10 raised to minus 3 upon 100, which is 1 into 10 raised to 5. So now we've got both the strain values. Similarly, we can also calculate the stress values. P upon A, area 1, P upon area 2, that is 1 Newton per millimeter square, and stress in the second bar is 2 Newton per millimeter square. Or else you can also use this equation to solve the stresses in the first bar and the second bar. Now if you notice, whatever answers we have got here are the same that we got in the numerical method. Sorry, the analytical method. See, so from this we can understand we have used two different approaches to solve the same problem. One was the analytical method and the second one was the numerical method. But the answers that we got using both the methods are similar. So with this you must have understood what is a analytical method and what is a numerical method. Now let us discuss about some other important concepts that will be needed in understanding CAE. The first one of which is degrees of freedom. There are 6 degrees of freedom and it is defined as the least number of independent coordinates required to define the configuration of a system in space. If you see the below figure over here, you will find that at node number 1, the degrees of freedom available is 0. That means it is completely fixed over here and hence there is no translation movement allowed, nor there is any rotational movement allowed over here. Similarly, at node N2, the degrees of freedom available is 1. That means only translation in x direction is allowed over here. So in this figure you will understand what is the meaning of degrees of freedom. Next is boundary conditions. The boundary conditions are used to eliminate the unknowns in a system. That means if you see the below diagram over here, at node number 1, the displacement, that is x1, will be completely 0 because as the degrees of freedom over here is 0, there is no translation nor rotational movement, hence there will be no displacement over here. So x, that is the displacement at node number 1, will be 0. So x1 is equal to 0 becomes a boundary condition. And at node number 3, there is a load acting of 200 newtons. So P is equal to 200 newton also becomes a boundary condition. The next important topic that we are going to discuss about is elements and element sheets. When we talk about FEA, the most important thing to understand is meshing. We will be discussing about meshing in our further chapters. But now we will discuss about the factors on which meshing depends. There are 5 factors on which meshing depends, and they are element types, element shape, element order, element size, and connectivity. So let us understand what this is. Okay. There are 3 types of element types: 1D elements, 2D elements, and 3D elements. Now let us discuss about these element types. The first element type is 1D element. 1D elements are also called as line elements. If you talk about the element shapes in 1D elements, it is just one single line with 2 nodes. For defining one line element, minimum 2 nodes are required. This element will be called as the first order element or the linear order 1D element. You also have this, if you see over here, this is also a 1D element, but the difference between this element and this element over here, that you will have a presence of a mid node over here. This element is called as a quadratic order element or a second order 1D element. In element orders, there are 2 types of element orders: first order elements and second order elements. First order elements do not have the mid nodes present, whereas the second order elements will have a presence of a mid node. The 1D elements can be used for trusses, beams, rods, pipes, bars, and also springs. So these can be applied in all these cases. The 1D elements can be applied for all these cases. The next element type that we are going to talk about is 2D element. 2D elements are also called as shell elements. When the thickness of a model is less than or is equal to 1/10 of the longest dimension, we can consider that to be a 2D problem. The element shape involved in 2D elements is triads or quads. Triangular element needs 3 minimum nodes to define the triangular element, and quad elements require 4 minimum nodes. This is called as a first order triangular element, and this is called as a first order quad element. On the right hand side, if you see, again we have a triangular element, but this is a second order triangular element. So here you will see that there are 6 nodes present in this, whereas in a quad element, second order quad element, you will see that there are 8 nodes present. When you talk about 2D elements, 2D elements are actually used in 3 cases. There can be plane stress 2D problems, there can be plane strain 2D problems, and there can also be axisymmetric 2D problems. Plane stress problems can be used when the stresses in the z direction is 0. That means the thickness in the z direction is very small as compared to the other dimensions, that is in the x and the y. Therefore, the stress induced in the z direction is very less or negligible. Hence, we consider that the stress in the z direction is 0. So, all these problems will be called as plane stress 2D problems. Plane strain problems is nothing but where the strain in the z direction is 0, where the length is very large as compared to the cross section of the design. For example, if you take an example of a railway track, the cross section of the railway track is very small as compared to the length of the railway track. Hence, the change in length along the z direction, that is along the length, will be very small or negligible. Hence, we say that strain in the z direction is 0. These problems will be called as plane strain 2D problems. And finally, we also have axisymmetric 2D problems. Wherever the model and the loads are symmetric about an axis, those problems will be considered as axisymmetric problems. For example, pressure vessels. Pressure vessels are actually the best example that we can have for axisymmetric problems. Now, after 2D, we will be also talking about the 3D elements. 3D elements are also called as volume elements. The element shape involved in 3D elements is tetrahedral. The name tetra is given because this element will have 4 faces, and it also requires 4 minimum nodes to define a tetrahedral element, that is a first order tetrahedral element. When you look at the right hand side, you will see a second order tetrahedral element which has 10 minimum nodes. Then the next shape involved in 3D elements is hexahedral. The name hexahedral is because it has 6 faces. A first order hexahedral element will have 8 minimum nodes to define it. And on the right hand side, you can see a second order hexahedral element which has minimum 20 nodes. So these are the types of elements, the element shapes, and the element orders. The one more factor that is remaining is connectivity. Connectivity is nothing but we need to understand whether the model is properly connected or not. There should be no overlapping geometries, neither there should be gaps in the geometry that we are analyzing. Hence, whenever you create a model in a CAE software, or whenever you import a model in a CAE software, you need to first check the connectivity of the model, whether they are intersecting or whether they are gaps. So that is another factor that has to be taken into account when you start meshing, that is connectivity. Next, let us discuss about the general procedure that is involved in a FEA. Every analysis procedure starts with setting the type of analysis to be performed, whether it is structural analysis or thermal analysis or modal analysis, followed by creating of the model. Then meshing the model, that is, we will break down the model into finite elements, and after that we will apply the material properties and boundary conditions. Next, we will be in the CAE software, the equations or the matrices will be created, and after that these equations will be solved, and after solving these equations we will get the results. So this is the entire procedure that is involved in a FEA software. Now further, these steps are divided into three main categories, that is pre-processor, solving and post-processor. So if you see, from defining the type of analysis to application of boundary conditions, this complete stage is called as the pre-processor. After that, creation of equations, solving the equations, all this comes under the solving stage, and finally checking the results or interpreting the results comes under post-processor. So these are the three stages that are involved in FEA. After that, let us talk about the assumptions in FEA. Now there are many assumptions that are there in FEA, but we will be only considering those assumptions which are necessary for our analysis. So these assumptions are assumptions which are related to our geometry, assumptions that are related to our material properties, and also assumptions that are related to our boundary conditions. All these assumptions that are mentioned over here, which are with respect to the geometry, material properties or boundary condition, is mentioned in your reference guide on page number 10. So you can refer your reference guide for understanding these assumptions. Let us move to the next topic, the types of engineering analysis. Now there are, if you see on your screen, types of engineering analysis. The engineering analysis are of two major categories, structural analysis and thermal analysis. The structural analysis is further divided into static analysis, dynamic analysis, spectrum analysis, buckling analysis, and explicit dynamic analysis. Further, dynamic analysis is divided into modal analysis, harmonic analysis, and transient dynamic analysis. Thermal analysis is further divided into steady state thermal analysis and transient thermal analysis. We will be discussing about the individual analysis when we start performing the analysis. So in the further chapters, we will be discussing more about the types of analysis. There are some more important definitions and terminologies that are given in your reference guide, which are related to your basic engineering concepts. So kindly go through the reference guide to revise all these definitions once again. Next, we will be talking about the types of materials. In engineering, the materials are classified into three major categories, that is isotropic material, orthotropic material, and anisotropic material. Isotropic material are those whose properties are not dependent on direction, which means they have the same material properties in all the directions. The material properties are defined by Young's modulus and Poisson's ratio. Example of an isotropic material can be taken as steel. The next is orthotropic material. These materials are those whose properties are unique and independent in three mutual perpendicular directions. These materials have three mutually perpendicular planes of symmetry. So the material properties are defined by different values of Young's modulus and Poisson's ratio in each of the axes. The best example that can be given for an orthotropic material is wood. Next, anisotropic material. Anisotropic materials are those whose properties vary with direction, but there is no plane of symmetry here. That means the material properties do not behave similar in all the directions. Example is composite materials. With this, we have finished discussing the basic introduction that is required for understanding CAE and FEA. In the previous chapter, we have discussed about the introduction to CAE, and we have understood some basic concepts and fundamentals related to CAE and FEA. Now let us start with chapter number 2, that is Introduction to Ansys Workbench. Ansys Workbench is a CAE software which is developed by Ansys Incorporation, which is a US based company. We are going to use Ansys version 14.0 for this video streaming purpose. The latest version in the market of the software is 16.0. We can generate 3D models, FEA models, and perform analysis and generate the results using this particular software. Now let us discuss about the Ansys Workbench features. It links with all the major CAD softwares from where we can import the models. That means if you are not going to create the model in Ansys Workbench, we can also import them from different CAD softwares. It automatically detects the contacts between the parts. So whenever we are dealing with assemblies, the contacts between the different parts of that assembly is automatically detected. That means I don't have to manually define these contacts. The user can use this particular software for complete analysis procedure. So the software will help you from the start till the end of the analysis. There is an easy drag and drop linking tool available, due to which the analysis time can be reduced considerably. We will see what this linking tool is when we enter the software and we start doing the analysis. The complex projects can be saved for further use. So you can reuse the projects that are very complex. That means I don't need to recreate the projects again and again. So these are some of the features that Ansys Workbench has. Now let us talk about the analysis that can be performed in Ansys Workbench. So these are all the types of analysis that can be performed in Ansys Workbench. You can see them on the screen. We have design assessment, electric, explicit, harmonic, IC engine, linear buckling, magnetostatic. But out of all these analysis, we are only going to study the ones that are marked in bold, that is static structural, modal, steady state thermal, linear buckling, and transient thermals. So these are the types of analysis that we'll be studying in our coming chapters. Now let us talk about the Workbench GUI, that is the graphical user interface of Ansys Workbench. You will see over here that this is the title bar. The title bar shows that what is the project that we have opened and what software we are using. Then we have the main menu bar over here. After that, we have the standard toolbar where we have options, the regularly used options like new, open, save, save as. Then we have the project schematic window where all the projects will be listed. Whatever analysis you are performing will be listed in the project schematic window. Then you have a toolbox. You have different types of systems that are available over here. We will be discussing about the toolbox later. And then finally you have the status bar. Let us go to the software. So this is the software interface. Title bar, main menu bar, standard toolbar. We have the project schematic window. We have the toolboxes over here. You also have a properties toolbar over here, and finally you have the status bar. Now let us understand about something called as toolboxes. The toolboxes actually consist of major systems. We have 4 major types of systems that are there in the toolbox. We have the analysis systems, then we have the component systems, then we have custom systems, and finally we have the design exploration toolbox. So the toolbox actually consists of all these things. Then we have the project schematic window. The project schematic window actually captures the project and the workflow of your project, providing a visual representation of the objects in the project and their relationship with each other. So let me show you one of the projects that is created. So this is one of the project which was previously created. These are all the different types of analysis that are performed in the project schematic window. So here you will understand that the project schematic window actually captures the project and the workflow of your project, how what analysis have you performed, how they were performed, what is the link between the two analysis systems. All those things are captured by the project schematic window. In the project schematic window, you can add new projects from the analysis systems. So let us understand how to add new projects. For adding a new project in your project schematic window, there are three different methods to do it. You can either drag an analysis systems, you can drag it, use your left mouse button to select it from the analysis system and then drag it to this green colored area that you see and drop it. So that analysis system will be added over here. Then you can rename that analysis system. It is always better to rename the analysis system so that you understand what is the analysis that you are performing. So I can write down over here whatever type of analysis that you are going to perform can be renamed. This is one of the methods to add an analysis system. The second method is right click in the project schematic window and add a new system. And the third method is you can double click on an analysis system to add it in the project schematic window. So these are the three methods by which you can add an analysis system to your project schematic window. Now once the system is added, there are different types of steps that you can perform on an analysis system. Now what are they? You can rename an analysis system. For renaming, you can click on this arrow over here and you can go for the rename option to rename it. You can rename them over here. So you can rename an analysis system over here like this. After renaming, you can also delete a system. So if I want to delete any system, I can just click over here and I can say delete. So that particular analysis system will be deleted from your project schematic window. Similarly, you can also duplicate a system. For example, now if you'll see over here, I already have an analysis which I have performed. I will just show you this. Okay. Now if you see on your screen, I have a plate with a hole. The model has been created. We have also performed the analysis and I also have some results for that. Now in this I have a geometry and in this geometry I have a hole over here. Now let us say I want the same geometry and I want the same loading conditions, but the only change in this geometry is that the hole diameter is changing. So rather than to perform the same analysis all over again, what we can do is we can duplicate this system. So I will click over here and I can say duplicate the system. So what happens over here is you will get a duplicate system of the same analysis system. So when you duplicate a system, you will get same geometry, same engineering data, same meshing conditions, same boundary conditions, and it is repeated again. Once you get that, you can again rename this analysis. I can say and then I will enter into the geometry and I can make changes as per my requirements. So in this case, what I need to do is I need to change the diameter So here the diameter is 200, I need to make it as 185. So my design changes and then I can come back over here and redo the analysis. So everything remains same. I just need to remesh the model. I'll just remesh it. All the boundary conditions remain same, and I will just come over here and I will solve it so that all the results are again achieved. So if you see over here, you have actually saved a lot of time because you did not have to create the model again, you did not have to mesh it again, you did not have to give the boundary conditions again. So by duplicating an analysis system, you are actually copying the previous system and you are getting your results. Now these results are for a model whose diameter has been changed to 185. So now I have two analysis systems. Here in this case, in this system, I have the geometry whose diameter is 200. And in this case, I have the same geometry, but the diameter of the hole over here is 185 units. So you can solve for two different conditions. For this purpose, you can use the duplicating system option. After your work is done, you can save the project. You can actually do it from the standard toolbar, or you can go to File and you can click over here, or you can also use the shortcut Ctrl S to save the project. After that, you also have something called as Save As if you want to save the project in a different format by a different name. Now let us understand how to open a previously saved project. For opening a previously saved project, you can click over here on the standard toolbar on the Open button, or else you can go for File Open, or you can use the shortcut Ctrl O. And you can select the previously saved projects. So I can select the project that I want to open and I can reopen them. You also have some options like archive a project and restore archive. Now let us discuss about what is the meaning of archiving a project. Now let me give you an example. I have a project over here which I have already created, whose name is buckling analysis and benchwise assembly. Now this project, whatever I have done, when I save a project, what happens is, along with the project, now see, if you see, this is the project that we have saved, whose extension is .wbpj. Along with this project, you also have some supporting files that will be saved. If you see, there is one more folder which gets created, and there are some user-defined files which are the supporting files that automatically get created when you save a project. Now, let me show you the folder. Now see, this is the project that we have saved, and here you have the supporting files that have been created along with the project. Now due to some reasons, I need to shift my work which I have performed on this computer to another computer. So if I only take this project file into a pen drive and I copy it to another system, that project will not open there because you have not copied all the supporting files of that project. So to be on a safer side, whenever you want to transfer a project, Ansys Workbench project, from one computer to another, it is always better that you use the archive project option. Whenever you use an archive project option, what happens is the entire project and its supporting files will be zipped into one folder, and the extension becomes .wbpz, and it will be saved in this format. So what happens, along with the project, all the supporting files of that project will be zipped into a file. And what you can do is, after that, you can take that particular zip folder. Can you see over here? This is the zip file that is created. You can take this zip file on a pen drive and take it to another computer and save it over there. Once you save that zip file over there, whenever you want to open that, I can go and I can say restore archive. So what happens is, when you restore that archive folder, This is the archive file, and when I say open, what happens is it will extract all the data from that zip folder, and it will ask you for a new saving location for that project which is available in that zip folder. So you can give a new project location and you can save it over there. So with the help of this option, that is archive project and restore archive project, you can copy files from one system to another system. So now you must have understood the graphical user interface of Ansys Workbench. What is the meaning of a toolbox? What is a project schematic window? How to add a new project? How to add a new system to the project window? We have seen the 3 methods by which you can do this. What is the meaning of renaming the system, deleting the system, duplicating a system, saving the project, opening a project, archiving a project, and extracting the archive file. Next, let us discuss about the units in Ansys Workbench. A unit system is a collection of preferred units for the base, common, and other quantity types. These are the unit systems that are available in Ansys Workbench. We have the metric unit system, which is the default unit system, where mass will be in kgs, length will be in meters, seconds, degrees Celsius, amperes, force will be in newtons, and volts. Similarly, we have one more metric unit system where the mass will be in tons, length will be in millimeters, time will be in seconds, temperature in degrees Celsius, the current will be in milliamperes, force is in newton, and millivolts. And we also have another unit system which is US customary, where the mass will be in lbms, length is in inches, seconds, degree Fahrenheit, amperes, force is in pound, force will be in lbf, and the volts. Then we have one more unit system as SI unit system, where these are the quantities like kgs, meters, seconds, kelvins, amperes, newtons, and volt. And then you have one more unit system which is US engineering, where we have lbm, inches, seconds, rankine, amperes, lbf, and volts. Now, these are all the default unit systems that are available, and please make a note that these default unit systems cannot be deleted, but you can create new systems of your own if they are needed. So now let us understand, if you want to create new unit systems, how to do that. So we come to the Ansys Workbench project window. Click over here on the Units tab in the main menu bar, and we will come to Unit Systems. Now once you come to the unit system, you can see over here that these are all the unit systems that are available. By default, we have some 16 unit systems that are available. But if you notice that here outside, you can see only 5 of them. Why? Because all the others, if you see from here, the others are suppressed. Because they are suppressed, I cannot see them outside. But if you remove this suppress option, close it, and you come back and see over here, that unit systems will be added and will be available outside. So if you want to see any of the unit systems, you can just remove the suppress tick from here. So these are the default unit systems that are there. Now let us say if you want to create your own unit system, what you need to do is, you need to select the unit system and click on the duplicate button over here. You get a new unit system, and then you can rename it. Once you have renamed it, you can see all the base quantities. So in this particular unit system, I want to measure the angle into degrees. The chemical amount or the current should be into milliamperes. The mass should be into kilograms. The time should be into milliseconds. Pressure should be into bars. Forces should be into dynes. Length should be into microns. So I can create this unit system where all the quantities I can change according to my needs. And then I can also say close. So now if you see, you have one more unit system over here which is called as the user defined unit system, which you have created. Now this unit system that you created can be deleted. I can delete this unit system. You can also export this unit system to an XML file which can be used later on, or you can also import it. So suppose if I want to export this unit systems to one of my colleagues, I can export it. Or let us say if my colleague has created some other unit system and I want to import it, I can also import it. So the file format is .xml format. So this is how you can create your own unit systems and manage the unit systems in Ansys Workbench. Now let us discuss about the file formats that are available in Ansys Workbench. If you see on screen, these are all the main file extensions that are used in Ansys Workbench, which you should know so that you recognize the files. So for a Workbench project file, the extension is .wbpj. For a archive file, the extension is .wbpz. .engd is an extension for the engineering data file, which stores all the material information. Then we have .agdb extension, which is for the design modeler file. Then we have .fedb, which is an extension for FE modeler files. .cmdb, which is an extension for the meshing file. .mechdb, it is mechdb, which is an extension for the mechanical file. .rsx, which is an extension for mesh morpher. .ad, which is an extension for the Ansys autodynamic file. .dxdb, which is an extension for design exploration file. .bgd, which is an extension for BleedGen file. .db, which is an extension for the mechanical APDL file, which is Ansys classic file. .cas, .dat, .msh are all extensions for FLUENT files. .cfx, .def, res, .mdef, .mres are all extensions of CFX files, and .cmdb is an extension for CFX mesh files. So now you know what are the extensions. Out of this, we will be majorly working on WBPJ, WBPZ, ENGD, AGDB, CMDB, .db. These are the most commonly used extensions that we will be using in the coming chapters. Now let us understand the components of a system. Every item that you add to your project schematic window is called as a system. A system is comprised of individual component systems called as cells. Now every analysis system has some common cells that occur in every analysis system. Now that is engineering data, geometry, model, setup, solution, and results. In this, engineering data cell consists of all the material information that is required for the analysis. The geometry cell consists of the model that is required for the analysis, and the model cell consists of all the mesh data, the boundary condition, load information, and all the other analysis settings that are required for the analysis. So these are the most common cells that occur in every analysis system that you add. Now let us discuss about the cell states. Now whenever you add an analysis system, you will have some cells that will appear in every analysis system, and there will be a status that is adjoining with every cell that you add in the system. So now let us understand these cell states. If you see a blue colored filled question mark, then it means that it requires attention. If you see a blue colored question mark but which is unfilled, that means there is no data and it is unfulfilled. If you see a green colored tick mark next to a cell, that means that cell is up to date. and that information from that particular cell can be transferred to another cell. If you see a green colored symbol like this, it means that cell requires refresh. It needs to be refreshed. If you see a green colored arrow with a yellow colored arrow, green colored tick mark with a yellow colored arrow, it means input changes are pending. Let me show you this. Now if you look at this analysis system, we have given all the information, and all the information has been given and it has been performed. So you see a green color tick mark everywhere. Now in this case, if I go and make any changes in any analysis system, for example, if I make some changes in the geometry, now if you see, we have one geometry over here. The dimensions are 50 by 10, the length is 50 and the width is 10. Let me make the width as 25 and I will generate the model. So the changes are done. When I close the geometry, can you see now the cell states have changed? The model now requires refresh. Now because the upstream data means just above this model there is some data that has been changed. That is why this cell now requires some refresh. And once you refresh this, it shows that this input will change. So if you look at the symbol over here, input changes pending, it is this symbol over here. Okay. Then if you see a yellow colored thunderbolt, that means that cell requires update. If you see a refresh button with a cross mark, that means the refresh has failed. Means if you have tried to refresh but the refresh has failed due to some reasons and you need to refresh it again. Similarly, if you see a yellow colored thunderbolt with a cross mark, red colored cross mark, that means the update has failed and you need to update that cell again. If you see a question mark, blue colored question mark with a cross mark, that means the update has failed and attention is required. That means some data has been wrongly entered over there and you need to quickly attend that cell so that you make the corrective actions over there. If you see a yellow colored thunderbolt with a sand clock, that means the actions on that particular cell are pending. And if you see a green color tick mark with a pause button, that means it is interrupted. That means you have paused the solution for some reasons and we want to continue it later on. So these are the cell states that you need to understand. So all this is, we have understood some basic things about the Ansys Workbench GUI. We have understood the features of Ansys Workbench over here. We have also understood what is a project schematic window, how to add analysis systems, how to work on an analysis system, what are the different types of toolboxes, what are the unit systems, what are the file formats, and what are the common component systems. We will now begin with the next chapter, that is sketching and part modeling in Design Modeler. Let us first understand what is Design Modeler and why is it necessary. For any analysis that we perform requires a part model. We have discussed the same thing in the general procedure of FEA, that before starting of any analysis you need the part model. So this part model which is required for our analysis can either be created in Ansys Workbench or it can be imported from any other CAD package. The part models that can be created in the Design Modeler, and these parts that are created in Design Modeler are parametric and feature based. Whatever models we create in Design Modeler are a combination of sketched and placed features. The sketched features are those which require a sketch to be drawn first and then the feature will be added, and the placed features are those which do not require any sketches. The Design Modeler window can be accessed from the geometry cell. The geometry cell can be a standalone system or it can be associated with any other analysis system. Now you can see two images over here, that the geometry can be a standalone system or it can be associated with any other analysis system. So first let us understand how to add this system. if you want to add a geometry cell as a standalone system, in component system you have this geometry cell over here. You can add this separately so it becomes a standalone geometry system, or else you can add any analysis system in which you will get the geometry cell. Okay. To enter into the geometry cell, you can either right click on it and say new geometry, or else you can double click on it. Once you double click on the geometry cell, you will enter into the design modeler window. Now the design modeler window is the same thing that you are going to use for creating your models in Ansys Workbench. Now the first thing that it will ask you to do is, as soon as you enter the design modeler, is set the unit system. Now if you look at this very carefully, you have some options over here where the length can be decided. The length has to be, whether you want the length to be into meters, centimeters, millimeters, micrometers, foot, or into inches. And just below that you have some other options. For example, always use project unit. Now what does this mean is, if I select this option, always use project unit, all these options become hidden and the unit system will be the same as you have set in the project window. Let me show you this. In the project schematic window, the unit system is set to SI unit system where the length is into meters. So that means if I select this option over here as use project unit, the unit will be set to meters. Okay. If I select the project unit as foot and inches, if I use US customary or as US engineering, where the unit system is set into inches, can you see now the unit system has set into inches. Okay, so that is always use the project unit. Now if I select this option, next time whenever I open the geometry, this dialog box where you have to select the unit system will not appear. Please make a note of it. If I select this option, next time whenever I open the geometry cell, this dialog box will not open and the unit system will automatically be set to whatever unit system you have set in the project window. If I say always use selected unit, that means if I make the unit system, if I say that I want to use millimeter for the current geometry cell, and if I say always use selected unit, that means next time whenever I open a geometry cell, the unit system will automatically be set to millimeters. Again, it will not ask me to change the unit system. Have you understood? Please understand, if I select always use selected unit, that means whatever I have set now, the same will be carried forward for all the other geometry cells. Now there is one more option. Now currently, because the unit system is set on millimeters, there is one option, enable large model support, which is hidden now. Enable large model support is only will be accessible only when you set the unit system as meter or as foot. Because these two unit systems are large, only then it will be available. So you can create large models and it will support your large models when you use meters or foots. It will become grayed as soon as you set to something as a smaller unit system like centimeters, millimeters or inches. Okay. So you will set your unit system first, okay, and then you will enter into the design modeler. Now first let us understand about the design modeler graphical user interface. You will have the title bar, you have the main menu bar, then you have certain toolbars over here which will be used as per their need. Then we have a tree outline where all your features, datum, planes will be listed over here. As soon as you start creating your models, the features will be listed one by one over here. Then you have a sketching tab and modeling tab. If I click on sketching tab, you will enter into the sketching mode. If I click on modeling tab, you will come back to this window where you can use your feature tools. Then you have a details view which shows you the information of the object, the features that you select. Then you have your graphics area. This over here is called as the ruler. Can you see this? This is called as your ruler, which shows you the unit system that you are using, and also shows you the tentative length of your model. We will see how to use the ruler when we start creating the model. Then we have your model view and the print view. Print view shows the print view of your analysis. Then this over here is called as a view triad. View triad is nothing but as you rotate your model, it shows you the views, the XYZ axis. And then you can see a blue colored sphere over here, which is called as the ISO ball. As soon as I click on the ISO ball, it will set the view as the isometric view. And then we have a status bar over here. So this is the graphical user interface of Design Modeler. Now once you come into the Design Modeler, you can see the three default planes, that is the XY plane, YZ plane and the ZX plane, which you can use for creating the geometry. So now let us see how to create a sketch and how to create the model. So we will be seeing how to create the sketches, and we will see how to add the base features like extrude and revolve. So let us start. So for creating the sketch, the first thing that you need to do is you need to select your base plane. On which plane do you need to start creating your sketch? I'll select the XY plane, and then we will click on the sketching tab. As soon as you click on the sketching tab, now your view changes and you can see some different tabs over here. You have the draw tab, modify tab, dimensions, constraints and settings. In the draw tab, you have all the tools that are required for sketching the sketch. That means you have all your sketching tools. In modify tab, you have all the modification options like how to trim the sketch, adding fillets, adding chamfers, cutting, cut, copy, paste, all those. Then we have the dimensions tab, by using which you can add dimensions to your sketches. Then we have the constraints tab, where all the constraints are available, geometric constraints, which you can add to your sketches. And then you have the settings tab, where you have settings like whether you want to see the grid. See, I want to see the gridding. I want the snaps to be on so that the mouse snaps to the grids only. I want major grid spacing as 10. What should be the grid spacing and what should be the snaps value? You can enter those values over here. Okay. And then you have an option over here which is look at face. As soon as I click on this, my sketching plane becomes normal to my screen. So you can use this to reorient your sketching plane. And now we will start sketching the sketch. So in draw tab, we have options like line, tangential line, line by 2 tangents, polyline, polygon, rectangle, rectangle by 3 points. You have oval, circle, circle by 3 tangents, arc by tangent, arc by 3 points, arc by center, ellipse. And you have the spline option, and you also have the construction point and construction point at intersection. So these are all the sketching tools that you can use. So as per your requirement, you can use all these sketching tools and create your sketch. So let us start creating the sketch. If you want to use a line, you have the line option and you have the polyline option. Now suppose if you need the line more than one time, you can directly start using the polyline. Once you select the line over here, if you see, when I come to this construction line, I get a symbol over here which is C. That means your line will be coincident on this construction line. If you see a symbol P, that means the point is coincident on a center point. It is coincident on a point. I'll use a polyline and I can start creating my sketch. Now if you see, we are getting a symbol V. That means the line is going to be vertical. If you need to stop over here or you still need to continue, you can still continue. And now here I need to end the command. So I need to end the polyline. So what you need to do is, don't click on the last point. Just right click and say whether it has to be an open-ended polyline or closed-ended. In this case, I need a closed-ended polyline, so I will say closed-ended so that it automatically meets the first point that you have drawn. Now, if you see closely over here, this line over here is not horizontal, but I need this line to be horizontal. So I can go to constraints and I can say horizontal. So that line becomes horizontal. Now I need to add dimensions to my sketch. So I will click on the dimensions tab and now you can start adding your dimensions. So if you want to add, if you just be on the general option, you can just select the line and automatically the dimension appears. Now if you see, you are getting the dimension but you are not getting the value, you are getting just the name of that dimension, that is V1, and in the details view you will get the value also. So the value is 8.5 or something, so I need to make it as 20 units. I'll make it as 20. Similarly, I need to add other dimensions also. This dimension over here has to be 1 unit. This also has to be 1 unit. This has to be 20. Now I need to add the dimension from this point to this point over here. Now for this I cannot use the okay. Can you see I have used the horizontal distance and I have measured it. So this has to be 26. Similarly, the distance from here to here also has to be 26. And finally I want to measure this length, which has to be 240. So I have created my sketch. Now I want to add some constraints to it. I want this to be symmetrical. So I'll go to constraints. I'm selecting the symmetry option. The symmetry has to be added to this. So I'm first thing you need to select your construction line and then you have to select the points. So I can select this point, use control and select the other. Okay. And now I will add one angle dimension to this line and to this. So now if you see, the entire sketch becomes blue in color. That means this sketch now is a fully constrained sketch. Before giving the angle, okay, if I just click on undo, that means the angle goes. Can you see this line is still green in color? That means it is not fully constrained. Now once the angle is added again, it again becomes fully constrained. So this is my sketch that I needed. Now I need to add the base feature to it. So I click on modeling tab so that I come back to the modeling tab. And now over here we will be adding the material. So I will use the extrude option to add material to the sketch. So I'll click on extrude. You can see that the material is being added. First you need to select the sketch. So I'll select this sketch and I will say apply. So that sketch 1 is added. Whether you want to add material. Now because it is the first sketch, you will only get add material or add frozen. I will select add material. You need to select the direction. Now in this you have normal, reversed. I want it as both sides symmetric. Extent type should be fixed and then you have to give the value. So I will say that the value is 10 units. That means it will be totally 10. I'll say it has to be 20. Okay. Whether you want it to be a thin surface or not. And then we will have to say generate so that the material is generated. So this is the model that we've got. Now let us understand the mouse controls also. To rotate the model, press your middle mouse button and you can rotate it. To pan it, you can use control plus the middle mouse button and you can pan. And zoom in, zoom out is just scroll. You can also change your views by selecting the axis in the triad. For taking the isometric view, you can come to the iso ball. You also have some shortcuts for changing the views. You have the shortcuts which are assigned to the numerical keypad. If you want to select the front view, you can directly press the button 1 in your numerical keypad. So if you if you press 1, you will get the front view. If you press 2, you will get the bottom view. If you press 3, you will get the right hand side view. If you press 5, you will get the isometric view. If you press 7, you will get the left hand side view. If you press 8, you will get the top view. And if you press 9, you will get the back view. So these are all the shortcuts that you can access by using your keyboard. Okay, so this is how you can create the sketch and add material. Now let us see how to add datum planes. If I want to create some new datum planes, you have the options over here for adding the new datum plane. You can click on new plane and create a new plane. So I need the plane in the center of this too. So I'll say from plane, that I don't want to move the plane. I will say from plane, and I need to move the ZX plane. So I need to move the ZX plane by some value. So I've selected the base plane as the ZX plane, apply, and it has to move. If you see, red color shows the x-axis, green color is the y-axis, and Z is the blue one. So I need to move this into the Z direction. So I will say offset in the Z direction, and what should be the offset value? So I need to move this by 6 units. Okay, or I need to move it by 10 units. So you can give values and you can see that the datum plane is created, and then you can say generate. Similarly, I want to create one more datum plane. I'll again click on new datum plane, but this time I don't want to move from plane, I need to move from face. So I'll select the base face, apply, and then I need to move this again. I will say offset in the Z direction, and the offset value has to be 6 units again, and we will say generate. Similarly, you can create more datum planes. If you want to create datum plane from point and edge, you have multiple options: from point and normal, from coordinate system, by using 3 points. So all these options can be used for creating a new datum plane. Okay, now let us add more features. Now whatever planes I have created over here, for example plane number 5, I need to add a sketch on plane number 5. So to make sure that you add the sketch on plane number 5, first select the plane number 5 from your tree outline and then click on sketching tab, so that you create a sketch on this plane. Then click on look at face so that it becomes perpendicular, and create your second sketch. So I need to add a sketch over here. Okay, I'll give the dimensions. I need the distance between this point and this has to be 20. Then I need the dimension between this point and this, which has to be 30. I need one line. I need only one single line, so I will add the single line over here.
and the distance between this line and this has to be 15 units. Now I need the same line on the opposite side, so what I'll do is, instead of drawing it, you can just come to modify and use copy and paste options, or you can also use replicate options. Now see what we are doing. I want the same line on the opposite side, so I will say replicate this line. After selecting the line, you have to click the right mouse button and use these options: set paste handle, use plain origin as paste handle, and use default paste handle. Now what is this? This is nothing but, if you know AutoCAD, in AutoCAD you have to select a base point. This is nothing but the base point selection. So if I want to mirror this line about this point, this has to become my base point. So I'm going to say this is my base point, and then because I want to mirror it, what you should do is again say right click, and you can use this option flip horizontally or flip vertically. So I'm going to say flip horizontally. Can you see that line has, and then again use that base point to paste it so that it is exactly the mirror. I hope you've understood. And then I need to draw one arc over here between these 2 points. So I will use arc by 3 points. And then you can draw the third point. You can mark the third point. So this is my third point. Now I need to trim these lines. So I will come to modify and I will use the trim option. I don't need this, I don't need this, and I don't need this. And then you can start giving the dimension. So I need to give the dimension to this. I'll first give the distances. I need to give the distance between this point and this point. Okay, now let us mark all these dimensions. D5 has to be 45. Okay, I have made that as an equal distance. This distance is equal to this distance. R4 has to be 40. I need to give the dimension between. Okay, so now if you notice, we have created our sketch, which is again a fully constrained sketch, and now we will come back to the modeling tab, and now we want to add the depth. So if you see, the material is getting added on the opposite side. I will need to change it, so I will say reversed, say fixed, and we can give the value as 30 units, and I will add the material. Okay, similarly I need to add another sketch, but this time the sketch has to be on the ZX plane. So I have selected the ZX plane, and then I will click on the sketching tab. Okay, now let us start creating the sketch. Okay, I need a circle. The circle diameter be 40. I need to change the distance between this and this. This has to be 60. Okay, and now I need to add one polygon. Now the polygon should have 6 sides, so I will take 6 sides and then I will start drawing my polygon. Okay. After that, I'll come to constraints and make sure that this line is vertical. Also, I need to give the dimension. So this has to be 15 units. Let us say this has to be 18 units. And then we will come out, and now I want to add material to this. So again I will click on extrude. The sketch is this sketch 3. I need to add material, but it has to be on both the sides, and it should be 20. If you say generate, so this is a model that we have created using the sketches and extrude option. We can add fillets over here, but we will see how to add fillets and chamfers in the coming chapters. Here you have just understood how to add the basic sketches and base features like extrude. Now we will see how to use the ruler. Now if I want to measure this distance, I can use the ruler to understand what will be the gap between them. So I can understand that this gap is somewhere around 30 or somewhere around 30 units. If I want to measure this gap from here, so it gives me a tentative length measurement for which I can use the ruler. If you want to sketch something on any plane on this face, you can use the filter over here. You can use the face option, select the face, and then go into the sketching tab, look at face, so that you are going to create your sketch over here. Okay, dimensions, I need to measure the distance between this and this. I need the radius, so R3 has to be 3.5 and this has to be 45 yards. Also I need the distance between this and this, it has to be 7.5. Come out, and now this, and again use the extrude option. It has to be in the reverse direction, and here I need to make it as a cut material. So that much material is cut. Can you understand this? You also have something called as slice material. Now if you see, when I have said it as cut material, you have only one body. That means the material has got removed from the same body. But if you use a slice material option, and if I say generate, you will see two bodies being created. Now what exactly has happened? The first body is this. The second cut material has cut that much material from the first body and regenerated it in the second body. If I just hide the two bodies, see, that much material is being cut, this much is the gap, and if I hide this body, see, so these are the two bodies that are created. If you select add frozen, again you will get two bodies, but here the second body does not cut over here. If you see, this is the first body, there is no material being cut over here, and the second body has overlapped with the first body over there. Okay, we will see for what we are going to use the add frozen option. Later on we will be seeing this. If I use imprint faces is nothing but there is no body created, only a face imprint is created over here. If you see, the imprint of that body will be created as a surface, which can be used for application of load purposes. Okay, so this is how you will create your base features using your sketching options and extrude option. With that, we have understood how to create our basic sketches using the Ansys Workbench design modeler. That is solid modeling fundamentals. In this chapter, we will be understanding some more modeling tools like revolve, sweep and loft. While we are doing so, we will also be understanding some more sketching tools that we left out in the previous chapter. Now let us create this model. We will try to create this model using Ansys Workbench design model. So let us go back to the software. Let me add one standalone geometry again. We will enter into the geometry. Let us set the unit system again to millimeters. Now I'll try to create a sketch for the revolve feature. So first select your plane, in which plane you want to create your sketch. So I've selected the XY plane and now I've entered into sketching. And let us start creating the sketch. So again I'll be using my polyline. Now I need to finish the sketch over here, so I will say closed ended so that it closes. Now that we have completed our sketch, now let us start giving the dimensions. I need this dimension. I need the distance between this and this. I need the distance between this and this, and also between this and this. Now I'll go to constraint and I will say that this length has to be equal to this length. Now let us change the dimension. H1 has to be 28, then L4 has to be 87.5, then L5 has to be 67.5, V2 has to be 7 units, and V3 has to be 10 units. I'll add one symmetry constraint over here. So this is my sketch which is ready. Now we will come out of the sketching tab into modeling. I'll use the revolve tool. The sketch that has to be revolved is this. The axis of revolution has to be this, and the revolution angle should be 360 degrees. It is not a thin surface, and we will say generate. So this is the body that we have generated. So using the revolve tool, we have created the first face feature. Now let us add some more features on this. So I need to create a small cutout over here. So I'll select this face and I will enter into sketching so that I make sure that the sketch is on this plane. Now I'll use a circle to draw the circle tool. I need an offset of the circle, so I'll go to the modify option and we will use the offset tool. I'll select the circle and right click and say place offset. So the offset has to be in the inside direction or outside. You have to place it. If you need to finish it, use your escape button to finish the command. After that, you use your dimensions to give the dimensions. Now here, the inside radius or the inside dia this is 34. Okay, so this is 28 and this is 34. Now I'm going to draw one line over here, and the gap between this and this is 3 units. Now I need the same line on the opposite side, so I'll go to the modify option and use the replicate option, or if you want to mirror it, you can also use copy and paste. Replicate or copy and paste can be used. So replicate, I will select the line, right click, set paste handle, I'll select the center point, right click, flip horizontally, and I will use this again. So I've got my line. Then I'll go to modify trim. I don't need this and this. Now once we've created, now I need the same lines on 6 sides. So now see, I need to create a pattern, but in modify you don't have a pattern tool. So what we are going to do is we are going to use the replicate option only. Now see what, if I need 6 copies of these throughout the 360 degrees, the angle between the two will be 60 degrees. So I'll use replicate. I need to replicate this line. Use your control button and select the other line also. After that, can you see the R option? We will say R rotation angle between the two should be 60 degrees. I've given the R option. Right click, set paste handle. I need to again replicate it about the center point, and now right click and I will say rotate by R degrees. So what happens is your lines will rotate by 60 degrees, and paste it. Again I will say rotate by R degrees, paste it, rotate by R degrees, paste, rotate by R degrees, paste. And we need to finish it. Now here something is going wrong. I don't need this line, I don't need this line. I will use this replicate about this, flip vertically, and I will paste it over here. Okay, and now whatever is not needed you can trim them. So we will go, we will say trim, okay. And escape. Now let us exit. This is my sketch. I'll come into extrude option and I will say that this has to be a cut material, and I will say that it has to be through all, generate. Okay, it's not a complete sketch. Okay, now you can see that the extrude has been generated properly. So we've added a cut feature on this. Next we need to add some holes. According to this, we need some holes over here. So again we can come back to the design modeler. The hole diameter is 5 and it has to be on a PCD of 160.
So come back. We will again go into the sketching, but this time I need to create the sketch on this plane. I need to add a hole. PCD given is 160, so let me add the dimension between this and this center point has to be 80, half of 160, and the hole dia has to be 6 units. You can again use the replicate option to repeat the circle all over. So I can select replicate again. You can also right click, set paste handle is this 60 degrees, right click, rotate by R degrees, and we can say modeling, extrude. I need to cut the material, and I will say this time through to next. So this is my model that has been created using the revolve tool. Next we will understand how to create a sweep feature. A sweep feature is created by using a cross section and a path, where the cross section follows the path to create the desired model. So let us understand how to create the sweep feature. Set the unit system, and now start sketching your path. The first thing that you need to sketch for a sweep feature is the path. So I will come into the sketching tab. First select your sketching plane and go into the sketching mode. I'll use a polyline again, and I am sketching my path. Now here I need to keep it open, so I will say right click and say open ended so that the polyline stops. Let us give the dimensions. Now when you are giving the dimensions, if you notice, only the dimension names appear. So you can come to the dimensions option and say display, I want the values also. So you will get the values also. Now change the dimensions over here. This has to be 60. This has to be 45. And this over here has to be 75. Now I'll come to modify and I'll add some fillets. Now fillets, you can give the value of the fillet over here, or else just add the fillet first, and after that you can give the dimension and change the value of the fillet. So you will notice that all the 3 fillets have changed because they were equal radius. I can add one more constraint. We need to add symmetry in this, and the distance between this and this has to be 25 units. So this is my path. After creation of the path, you need to create a new datum plane for making the cross section. Now make sure that the cross section is always perpendicular to your path. So I need to create a new datum plane, and this time I will say that it has to be from pointer normal. So the base point where I need the plane is this, and it has to be normal to this line. Always remember, if I have selected this as the point, do not select this line for selecting the normal defined by. The point and the line should be separate. They should not be in the same geometry. Okay. And then I will say generate. So a new datum plane has been created. You can say right click, always show the sketch, that the sketch is always shown. Now I'll select the plane 4 and I will enter into sketching tab to make the cross section. So I need a circular cross section over here, and I'll give the dimension. Dimension over here has to be 20. Come back to the modeling tab, and now we will go into sweep. So the profile is this and the path is this. You will say generate. You can see that the sweep feature has been created. The sweep feature can also be created for adding material or cutting material. Because it is the first feature, first phase feature, you are not getting the cut material option. Okay.
Now I'm going to shell this sweep feature. So you have one thin surface option over here. Select that, and you have two options over here, three options: faces to remove, faces to keep, and bodies only. I am going to select faces to remove. So I need to select this face and this face because I want to remove these faces completely. And the thickness should be 5. If you see, you can see this has to be 3. So this is the shell that I have been created. Now I have to create one more feature. So I'm going to select plane 4. Now another point to remember is, if you want to create one more sketch on the same sketching plane, then select the plane and always say new sketch. Otherwise what will happen is, the new sketch that you create will get added up in the previous sketch. So always make sure that when you are sketching a new sketch on the same sketching plane, always make sure you say add new sketch. Now I'll select sketch 3 and then enter into sketching tab. And now I want to create another sketch. So I'll create the sketch. Dimensions, I'm going to add some dimension. This has to be 30, and I have one more. This has to be 15 units. And we will say extrude. This has to be 5 units. We will say generate. So this is the sweep feature. Similarly, you can add features and complete your sweep feature also. So the sweep feature can be created like this. Now let us understand the loft feature. In the loft feature, we can add material between two different cross sections or more. These cross sections can be different in shape and size, but need to be parallel to each other. So let us understand how to create this loft feature. I have added one new geometry standalone cell. Let us enter into the modeling design modeler. Set the unit system as per your requirements, and then select your first sketching plane. So here I have selected XY plane as the first sketching plane, and I will enter into sketching. Now here, for creating the loft feature, I am using an ellipse, and I will draw the ellipse. Once the ellipse is drawn, I will give the dimensions, where you get the minimum radius of the ellipse, minimum minor axis dimension and major axis dimension. Okay. Once the sketch is drawn, I will come out. Now I need another datum plane. So I'll create a new datum plane from the XY plane, which has to be transformed in the Z direction at a distance of 50 units. So I'll create another plane and I will say generate. I'll make sure that the first sketch is always seen, plane number 4, and I will say sketching, so that I create a sketch in the plane 4. Again I'll use an ellipse tool and I will draw another ellipse. I need to give dimensions to this ellipse also. Change the dimensions as per your needs, and then come back to the modeling tab. Once you are here, select the skin or the loft tool. You have two options over here: select individual profile or select all profiles. Now when you go for select all profiles or select individual profiles, make sure that the sketches are selected from the tree outline and not from the graphics area. So I'll select sketch 1, control and sketch 2 and say apply, so that you see that the profile 1 is sketch 1 and profile 2 is sketch 2. And then I will say that this has to be added as a material, and we will say generate. So you can see that the material has been added between the two sketches that we've drawn, and this is the loft feature that we have got. You can use the loft feature to add material and also to cut material if it is a second or the third feature. This is how to use the loft feature. We will now shift to the next chapter, that is place features and assembly.
When you start creating a model in Design Modeler, it involves a lot of features. These features can be sketched features or placed features. The placed features are those which require sketches before adding the feature, and placed features are those which do not require sketches before adding the feature. So let us understand how to add these placed features in Design Modeler. For understanding the placed features, I have already created one model. If you can see over here, we have already created this model. In this model, we have one hole which is there. Okay. Now I want to add some fillets over here. Now in Ansys Design Modeler, if you want to add a fillet, you need to use the tool Blend, and in Blend you have one option which is called as Fixed Radius. You can use this option to add a fillet. Now I'm selecting the fixed radius, and then you need to select the edges where you want to add the fillet. So I've selected these two edges, apply, and then you need to mention the radius of the fillet. So I'll write the radius value as 2, or let us say, and we will say generate. So you can see that the blend has been added. Similarly, I want to add one more blend over here. I'll select the two edges, apply, and the fillet radius is 1. So this becomes one of the placed features. Similarly, I want to add a chamfer. I'll select the chamfer option. I'll select this edge, and I'll select this edge. And I'll write the fillet value as 0.1 and 0.1. Generate. So you can see there is a small chamfer that has been added over here. If you want to change the distance of the chamfer, select. I'll make it as 0.25 and 0.25, and we will say generate, so that the fillet adds up. Now that the fillet is added up, now let us understand how to create a pattern feature in Ansys Design Modeler. Now you can see that there is one hole which has already been added. So for creating a pattern, go to the create option in the main menu bar and select the pattern option from here. Now in pattern type, you have 3 types, that is a linear pattern, circular pattern, and a rectangular pattern. Now in this case, I need to use a circular pattern. Circular pattern is where you will be copying a geometry about an axis in a circular manner. If you select linear pattern is if you want to repeat the feature in only one linear direction. But if you select a rectangular pattern can be used to create a pattern feature where you can repeat the geometry in x and y directions. First, let us understand how to create a circular pattern. The geometry to be patterned is this face. So I make sure that in my selection filter, I have selected the faces. I'll select this face over here and this face over here. Use your control key to select multiple faces. I'll say apply, and then you have to select the axis. So for selecting the axis, select any one plane from here. Now if I select XY plane, the axes are coming in this direction and this direction. I'll go for XZ plane. So I can see there's one axis over here, and this axis I have it in the center. So I will select this axis and I will say apply. I need evenly spaced objects. So how many objects do you need evenly? So in the entire 360 degrees of revolution, I need 2 more copies. One is there, I need 2 more. So that total becomes 3, and I will say generate. So you will see that the pattern has been created. So these are some of the placed features that we can add in Ansys Workbench Design Modeler. That is fixed radius, and we can also add chamfer. After this, we will see how to create an assembly. So for creating the assembly, this is we have already created. Now we will be creating this assembly that you see on your screen in our Ansys Design Modeler interface. So let us start creating this assembly. Let me add the geometry. Let us enter into a geometry. Set your unit system. I am setting my unit system as millimeter. And now we will start creating the assembly.
So first I need to select my sketching plane and I need to add my sketch. So I've selected the XY plane and I've entered into the sketching tab. I'll use my circle tool and create my circle. I'll give dimension. The diameter value for this circle is 180. Okay, I'll come back to the modeling option and we will use extrude option to add material to this. So I need to add material and the depth value is 20 and generate. So this is my first feature. Now I'm selecting this face and I'll go into the sketching tab again. And over here I create one circle . I give the diameter value to this. The diameter value of this circle is 14.5 and the distance is 30, 35 and the distance from here to here is 15. I'll exit and now again I'll go into extrude, but this time I want to say that this is cut material and the depth of this cut material is 8 units and I'll say generate. Now I'll select this face over here and again I will enter into the sketching tab and here I will create one more circle whose dimension of value is diameter is 10. Come back to the modeling tab. We'll go into extrude again. I'll say this is again cut material and it is through all. Generate. Okay, so we have got this hole. Now in this case I need to create a pattern of this hole again. Now we will go into the pattern option. I'll select the pattern. For creating the pattern, I'll select these faces over here. See what faces I've selected. That is my geometry. And in this case, I'm going to select it as a rectangular pattern. Direction, the first direction is this. Change the arrow direction. You can swap the arrow direction from here. And the offset distance is 70 units. After that, I need to select the second direction. So second direction is this. I'll swap the direction and the dimension is 30. I need 2 copy and here also I need 2 copies and we will say generate. So can you see that the pattern is created? The distance between this two is 70 and the distance between this two is 30. So this is my first model that has been created. After this, if you want to rename the models, you can also rename them. I can say right click and rename. I will call this as my base plate. Next, I need to create the second model. So now the second model is a bolt. So I have selected this face and I make sure that I say it is a new sketch. I'll click on sketch 4 and then I will enter into the sketching tab. Here I've created a circle over here. I'll give the dimensions and the dimension value again is 14.5 diameter. We'll come back to the modeling tab and now I will go into extrude option. I have to say that this is add frozen. Whenever you want to add this as a separate body, make sure you're selecting add frozen. So add frozen you can use to add a new body to your part. So I've selected this. Direction I will say is reversed and the depth is 8. We'll say generate. You will see that another model has been added. Now if you want, you can hide this body so that you can only see this. Again I'll select this face over here and I will go into sketching tab. Now here I create another circle whose dimension is 10. We will come into extrude, apply. Now here when we are selecting this, I will make sure again it is add frozen over here. The depth is 20, directions, and we will say generate again. So now you see that this is getting added as a third body, but this body has to be added over here. So now I'll go into create Boolean operation and I have to say that the two bodies have to be united. Now what are the two bodies that you need to unite? So I will select this body, control and the second body, and I will say apply. The two bodies have got selected and we will say generate. So this is my bolt. I can also rename it and say this is my bolt. You can unhide your body. So you can see that the body has been added up. Again you can go for pattern option, and here I again want to create a rectangular pattern. The geometry is this bolt. I am selecting a body for pattern. Direction, first direction is this. Swap the direction, apply, and the distance between is 30. I need 2 copies, and the second direction is this, and here I need 70. You've got 2 bodies. I will reduce this as 1 and this is 1. So you can see now the bolts have been patterned and you've got 4 bolts. Okay, next I come back to my base plate and I'm going to create another hole in this. I have added a new sketch on plane number 4, that is sketch 7. Select sketch 7 and go into the sketching tab. I'm going to create another hole over here whose diameter is 38. And we will come back into the modeling tab. I will say this is extrude and I want to say that it is going to be cut material and the depth is through all, generate. Okay, fine. So now currently I have 5 parts over here in my assembly. Now I want to add another part. For that I will come into the ZX plane and I will enter into the sketching tab. And now over here I'm going to use a polyline and create my sketch. I'll say closed ended. Now I'll start giving my dimensions. Okay, so this is 80, H3 is 20, this over here is 21, and this is 19. and I will give one more dimension, that is distance between this and this, that is 50 units. I will make this as a horizontal line, sorry, in this direction it is going to be a vertical line, and now I will give this distance as 50 units, or maybe 35. And now we will enter into modeling, and I will say that it has to be revolved. So the sketch to be revolved is this, axis is this, and it is going to be add frozen generate. So that gets added as another body over here, and I'll call this as circular shaft. Now you can add another features what you want to add over here. So I'm going to add a chamfer on this, whatever distances you want. Next I'm going to add another feature. I'll enter into the sketching tab. I select the rectangular tool and I draw this rectangle. After drawing this rectangle, we will give the dimensions. I'll give the distance between this and this. So this value over here is 5 units. This is 15. Let us say this is 18. 16 units. And this total is 30. And after that I'll add a symmetric constraint over here. Okay. After that I'll come into my modify option again. Copy. We are going to copy this. Right click, set paste handle. Copy all the 4, set paste handle as the center point, and I'll say flip vertically. Next we will come out in the modeling tab and we will again go to extrude, add frozen. Okay. So these are the two bodies that we've added. After that I will again go into the Boolean operations, and here this time I will say it has to be subtracted. So target body is this, and the tools that we have to subtract are these two bodies. So use your control key. So that is my second object. Okay, so like this you can create your entire assembly. Now if you see that the bodies are looking like transparent, so you can come to view option and say frozen body transparency should be off. So now you can see all your bodies. So this is how you will create your assembly in Ansys Workbench design mode. Next chapter that we will discuss is modeling techniques. In this chapter, we will be discussing about some important modeling techniques that will be used to create better designs. Ansys Design Modeler is a fully parametric modeling system in which we have a parameters tool over here which can be used to assign some relations to the dimensions. These relations will help us to control the design as and when required. So in this chapter we will be discussing about parameters, how to import models from other CAD softwares, and also how to create surface and line models. So let us start with parameters. Parameters is nothing but whenever you are creating a design in design modeler, if there can be some relations added to the dimensions, we will use the parameters tool to add these relations. If I use these relations, what happens is I can control the design in a much better manner by the use of these parameters. Now, how will we create these parameters and how will we add these relations? We will understand that with a simple example. In this case, what we are going to do is we are going to create this model, and these are the dimensions that we have to assign to this model. So let us start creating this model. I will add one geometry system over here and I will enter into the design modeler. Set your unit system as required. According to that diagram that we saw, it is into millimeters. So I have set my dimensions as millimeters. I will select the XY plane and enter into the sketching tab. Once I come over here, I will start creating my design. I'll create a circle first. And after creating the circle, I'll add the dimensions to it. Then I'll add the distance between the two circles. I change this distance to 158. This dia over here is 20. And this dia over here is 10. After that, I'll add one symmetry constraint between the two circles. After that, I'm going to draw two lines. This is my first line. And after drawing this first line, I'm going to paste this line on the opposite side. That means I'm going to mirror this line. Okay. After mirroring this line, I'll again go back to dimensions and give the dimensions between these two. And this dimension is 22 units. And then I'll add one symmetry constraint between the two lines. After that, I'm going to add two more circles. Then I'm going to trim whatever is not needed. So I'm going to trim this line. And this line over here. And then this circle. After that, I will again give dimensions to these circles over here, and then I'm going to change their values. So with this is my sketch which has been completed, which is a fully parametric sketch. After this, I'll come out into the modeling tab, and then I'm going to add some depth to this sketch. So the depth is 12 units. So this is the model that is generated. So now imagine if I need to change any of the dimension over here, I will have to again come into the sketching tab and then change the dimensions. Now let us assume that this connecting rod that I have created has some relations to it, means the dimensions are interrelated to one another. Now in that case, what we can do is I can have one controlling dimension over here which will control all the other dimensions. In this case, what we will do is we will keep the length, that is, we will keep this dimension L20 the controlling dimensions for all the other dimensions, according to which, now see, we will rename the dimensions first like this, and then we will give some parameters. We will assign these parameters to our design. So let us come back to design modeler. Okay. Now if you want to control these dimensions according to the parameters, the first thing that you need to do is you need to make these dimensions as driven dimensions. So can you see this checkbox over here? You need to add this checkbox so that it becomes a driven dimension. Now, whenever you make a dimension as a driven dimension, a dialog box appears over here and it shows the name of that dimension. The name of the dimension always appears as the datum plane name first, on which datum plane you have created the dimension, dot the dimension name. Now this can be very confusing if you have lot of dimensions in the design. So it is always better that you rename these dimensions. So now what I'm going to do is I'm going to rename them as per my requirements or as per you think. So I will call this as left hand side inner diameter, that is LHID. Okay. Then I will call this as right hand side inner diameter. This is my length, so I will call this as my length. Okay. Then this is my width. Okay. This is my left hand side outer it is not a diameter, it is a radius, but still I am writing it as OD. And this over here is my right hand side OD. So I have made all the dimensions as driven dimensions. After that I come back to the modeling tab. I click on this extrude. Even the depth, I want to control the depth of the model according to the length. So again this depth I'll make it as driven and I will write this is my thickness. Okay. So with this what I have done is I have added all the dimensions as driven dimensions so that they get added in my parameters tab. After that you can click over here in the parameters tab in the toolbar, or else you can come to tools and you can click over here, either of the options. As soon as you click on the parameters tab, you will get one window over here just below your model view and print view, where all the names will appear and their values will appear. In the design parameters you will get this information, and over here parameter dimension assignments, you can write your relationships, how and with whom you want to control the dimensions. So now what we are going to do is, as discussed, we are going to control all the dimension according to the length. So the length will be the controlling dimension in this design. So thickness, I'm going to add the relation for the thickness. I will say that the thickness is going to be length divided by 13.16. RHOD, that is the right hand side diameter OD, is going to be length divided by 12.15. I have calculated these values and now I'm writing these values. The left hand side OD is length divided by 7.9. Then the width is equal to length divided by 7.18. Length is equal to the length. I'm not going to change that because that is my controlling dimension. RHID, that is the right hand side inner diameter, is length divided by 15.8, and the LHID is going to be length divided by 8.32. When you come to the check values, you will see all the values change. Now what we need to do is, as my length is my controlling factor, let us say if I change my length to 125 units, you will see all the other values will change according to 125, and when I say generate, I'll get a new design. If I say that this is 250, the entire model will change and you will get a new model. I don't have to sit and change all the other dimensions because I have given some parameters over here with the help of which I change the length and all the other dimensions change according to the length because of these parameters that I have assigned. Okay, So this is how you can use the parameters and assign the parameters to your design. Once the parameters are assigned, you can close the design modeler and you will see that a parameter set is associated with this cell. So I can also click on this parameter set to change my dimensions over here. You can also change your dimensions over here and come back. So if I say that this has to be 120, you will see that a refresh button appears over here. So I can say right click and refresh. So it will get refreshed, and if you again reopen your model, you will get the new design as 120 units. If you see, it is going to be 120. So you can see that the parameter set will help you to understand or to control your design in a much better manner by the use of the parameters where you can assign the relationships. Now, after understanding the parameters, the next topic that we will understand is how to import geometries from other CAD packages. Now, Ansys Design Modeler, we have already seen how to create models in Design Modeler. Now we will understand how to import the models from other softwares. So the advantage of Ansys Workbench is that it is compatible with all the leading CAD packages that we have nowadays. So here we can import models from Autodesk Inventor, CATIA, Creo, Solid Edge, SolidWorks, NX. Apart from this, we can also import models in the IGS format, step format, parasolid formats. So we can import all these models. So let us understand how to import these models. So we will come to Ansys Workbench again. I'll open a standalone geometry cell. And here, if you want to import a model from other CAD package, right click on geometry and then you can come to import geometry. Now, I already have one NX CAD model. You can come to browse. I have many NX files, so I can come to this option over here and you can import the model. So let me import this model over here, which is the NX file. After you have imported this, double click on geometry again and then it will ask you for the unit system again. What is the unit system that you have to set? So set your unit system over here as required and then click on generate. So now the model will be generated as it is in your CAD software. So you can see over here that the model has been generated. So in this case, what we have done is we have imported the model from a NX software. Similarly, you can also import models in IGS format or in step formats. So let us say if I want to import a step file, I can come into import geometry, browse, and then you can import your IGS files or step files. So here you can see that I have some IGS models. I double click on the geometry option again and I need to check whether the geometry has been imported or not. I will again set my unit system and I will click on generate. So you can see over here that the model has been imported, but this time I have imported the model in an IGS format. So it is very clear that you can import geometries in all the possible formats from any CAD package or into any other format solid modeling software. So this is how you are going to import the models. So after importing the models, after understanding how to import the models, we will now shift to another topic, that is creation of surface models and line models. Now what is the meaning of surface models and line models? Now in the previous chapters that we've seen, we have already seen how to create 3D models. Now in the first chapter, if you remember, we have already discussed about 2D elements and 1D elements. Now what are these 2D elements and 1D elements? Whenever the thickness of the model that we are using for analysis is very small as compared to the other dimensions, what we discussed is you can convert that model into a 2D model. Now when you convert the model into a 2D model, what we are doing is we are simplifying the geometry to reduce the complexity of the analysis. Similarly, whenever you have truss problems, beam problems, pipe problems, what we do is instead of considering the 3D truss, you will be converting that into a 1D geometry. So what happens over here, the time taken for creating the geometry is also lesser, plus the time taken for analysis is also lesser because you are reducing the difficulty level of the problem. So here now we will understand, if I want to create a surface model or if you want to create a line model for 2D analysis or 1D analysis, how will you do that? Now in the previous example that we did for parameters, if you remember the dimensions, the thickness of the model was very small as compared to the other dimensions. So if you look at the dimensions, if you see these dimensions, if you look at the length, okay, the longest dimension over here is 158. The thickness or the depth of the model is 12 mm. So as compared to this dimension, that is 158, 12 mm is very less. So instead of considering this to be 3D, we can consider this to be a 2D model. So what we can do is we can convert this into a 2D model. Now for converting this into 2D also, there are two methods. If you are going to create this as a 2D model, what you should do is, when you are coming into the geometry tab, you create your sketch as you created for 3D. Okay, let me set the dimensions. And now over here, I am again creating the same sketch that I created for understanding the parameters. So I'll create my circle. Over here, I'll give the dimensions to the circles. I will also create the distance between the two circles. And now I will change the values. So this is 158, this is 20, and this over here is 10 units. I will add the constraint between the two. I will add a symmetry constraint over here between them. Okay, and then come over here, copy this line and mirror it. Okay, then I'm going to draw the other circles over here and also over here. Then I am going to give the dimensions between this and this has to be 22 units. I will make them symmetrical. Okay, and then I'm going to trim the unwanted sketches. Once this is done, I'll add my dimension over here and over here. So this is 13 units and this is 19 units. After that, I'll come back into modeling. Now, in the previous case, we added the depth, but now what we will do is we will convert this into a surface model directly. So for creating this as a surface model, you will come into concepts in the main menu bar, and we have one option over here, surfaces from sketches. I will use this option. First select your sketch as your base object, and then whether this has to be adding material or add frozen. I will say that this is adding material. Thickness, if you want, you can mention the thickness over here, or else you can mention the thickness when we go for analysis. We will see how to give the thickness in analysis. So now currently I will give the thickness as 0 and I will say generated. So now you can see that it has been converted as a surface model. This is how you will create the surface model. Similarly, if you want to, if let us say you have created a model in CAD. Okay, so now let us look at this example. Okay, if you look at this model also. Now this model, as we discussed earlier, we have imported this from NXCAD. Now again in this case, if you look at the model, if you look at the thickness, is very small as compared to the other dimensions. So now rather than considering this as a 3D model, what we can do is we can convert this into a 2D model. Now here we have not created the model over here, we have imported the model. So when you import a 3D geometry from a CAD software which can be converted into 2D, we have one tool over here in Tools tab that is called as Mid Surface. So what does this option do for us is it will extract the mid surface of the geometry and help us create a surface model. So I will click on mid surface. Now the selection method that we are going to use is manual. So now I have to select the face pairs. Now when you are selecting the face pairs, you need to take care of the selections. I have selected the first pair from inside. Then you need to select the opposite side, that is the parallel side of this face. When you are selecting the parallel side of this face, make sure you are pressing your control button. Press your control button and then click. You will see that the color changes. Now go for the second pair. Now when you are selecting the second pair, that time you don't need to click on your press your control button. I've selected this. When selecting the pair, you have to press your control button. When selecting the first face, you don't have to select control. Second face, you have to select control. Like this, continue and make sure you select all the faces. So you are going to select all the faces like this. One by one, just make sure, and the order of selection also has to be correct. For example, if I have selected first from inside, make sure all the faces are selected. First side should be inside and the second side is outside. So with this, I have selected all the faces. Now we will say apply over here and then we will say generate. Now you will see that the mid surface has been generated. So this is the second method to create a surface model. There are some more options that we have. Let us understand them also, how to create surfaces. Okay, I will come to this geometry. Now if you see, we have a solid model over here. In this case, I can also extract the mid surface, or I can say surfaces from faces. Surfaces from faces, you can select a face, apply, and I can say add frozen. Add frozen means that gets added as a separate body, and we will say generate. Now if you see, there are two bodies, one is a solid body and one is a surface body that we've added. Now when you take this into analysis, what we can do is, because there are two separate bodies, I can have a different material for this solid body and I can also have a different material for this. For example, if you are considering a wooden plank, now assume that this is a wooden plank and this is the sun mica that is on that. So I need to give a different material property for the wooden plank and for the sunmica. So I don't have to create this sunmica separately. What I can do is I can just use surfaces from faces and I can create this as a separate surface. So I have two bodies which can be used for analysis. So these are some of the options by which you can create surface models. Now we will understand how to create 1D models. Now as discussed, 1D models can be used in cases of trusses, pipes, beams, columns, rods. So we will take one example. I'll show you the example first. Okay, we are going to use this, we are going to create this line body. It is a truss problem. So first, let me add the geometry and then I will enter into the geometry. Once you enter into the geometry, please set your unit system and then enter into sketching. Now I will enter into the sketching tab and I will first create my sketch. I'll use a polyline to create my first sketch. I'll say this has to be open-ended and then I'll give my dimensions. So this length over here has to be 105 units and this width, that is h1, has to be 50 units. And then I am also going to give a symmetric constraint between these two. You also have many other constraints like fixed, horizontal, vertical. Okay, these are very simple to understand. Okay, now that the sketch is ready, I will come out into the modeling tab. Okay, now currently this is a sketch. Now what we are going to do is we are going to convert this sketch into a line body. So for converting a sketch into a line body, you need to go into concepts and select lines from sketches. So I'll select this option, select your base object. So my base object is this sketch and I will say generate. As soon as you say generate, you will see that that line body is created. But this line body does not have a cross section. Now whenever you create a 1D model, you need to assign a cross section to that 1D model. So now we will create that cross section. Again click on concepts tab and come into cross sections. Now you have all these types of cross sections that can be created in Ansys Workbench design model. I can have a rectangular section, circular section, T section, L section. There are different types of sections. Now for this model I need a L section. As soon as you click on the L section, you will get the L cross section and you will also see the dimensions over here. So in my case, what I'm going to do is I need the W1 to be 3, W2 to be 3, T1 and T2 is 0.5. Okay, so this is my cross section that I have created and now I need to assign this cross section to this line body. So again click on line body, cross section and select L1. So now the cross section has been assigned. Whenever you are working with line bodies and you are assigning some cross section, there is one more important thing, that is the cross section orientation. First thing is you need to switch on the visibility of the cross section. So go to view and say cross section solids. As soon as you do that, you will see the cross section. Okay. Now if I want to change the orientation, it means that the L section that is coming over here like this, I want to reorient it. Select the line filter from here and then select the line. And over here you can assign some rotational angles. Can you see the orientation changing? Similarly, I want to change the orientation for this and it has to be 180 degrees, so it changes. So in every case, I can assign some orientations. So like this, you can change your orientation of the cross section as per your requirements. Okay, now according to the figure, I need on the opposite side also the same thing. So now what I'm going to do is, rather than drawing it again, see what I'm going to do. I come to the create option and over here you have something called as body operations, or you can also go for pattern. I'll click on the body operation and I'm going to say that it has to be translated. Select the bodies that has to be translated. So I'll select line body from here, apply, and direction. So direction I'm going to select, or I can say coordinates also. And according to this, now it is in the Z direction, so I will say it has to be oriented by 50 units, and we will say generate. So the line body has been translated, and my sketch again remains here. So what I'm going to do, again I will say line from sketches, and again I'll add one more line body for this sketch. Add material, generate, and I'm going to assign the same cross section to this. Now I need to add line bodies over here also. Now in this case, if you want, you can again create a line over here, but now I don't need to create the lines again, because in concept you also have something called as lines from points. So in that case, I will select this point, control, select the other point, add. Similarly, add. Let's say generate first. So that is my first body. Again I'll go for lines from points and select this point, control, and select the other point, and make sure that it is add material so that it gets added into the body, and this, all these things become as one line body, and we will say generate. So now you can see that the structure is ready. If you want, you can see the visibility. If you don't want the visibility, you can switch it off. So this is how you need to create your line bodies. Now imagine if these structures had different material properties, then in that case, instead of adding the material, you need to make sure that it is add frozen. Whatever bodies are having different material, they should be separate, so that you can assign different material properties to each body. So that depends on the criteria, and according to that you can use add material or add frozen. Okay, so this is how you will create your 1D models. With this, we have completed the modeling part in Ansys Workbench Design Modeler. Now we know how to create geometries, 3D models, how to create 2D models, how to create 1D models, how to create assemblies, how to add features. There are some more options over here. That is, in body operations you can use move, delete. Okay, if you want to delete anything, if you want to delete a body, you can use the delete option from here. You can also create a mirror option by using the body operations. But these body operations will only work on bodies and it will not work on sketches. Okay. You also have some primitives over here which can be used to create predefined shapes like spheres, boxes, cylinders, cones, etc. Okay. So you can use all these options as and when required.